Hello, everyone. My name is Ali Hassan, and I'm the Director of Product and Strategy at Dell Networking. I hope all of you and your loved ones are safe and healthy in these challenging times. Thank you for joining. Today, we will talk about what Dell Networking is doing to make open source networking a reality with Sonic. Now, when a new infrastructure technology is introduced into the market, more often than not, it is a closed architecture. This allows the vendor to recoup their R&D costs by getting a first mover advantage. Now, if the technology gains wide adoption, market forces kick in and try to force the technology open. Dell, for our part, we have been that agent of change in the history of IT for both PCs and servers. And for the last few years, we have been executing on that vision for data center networking. Affordable, simpler, and open. That is our DNA. To set the context, we will start our story with the evolution of compute. Now, in the 90s, compute infrastructure was vertically integrated. There were multiple vendors, each offering their own operating systems, usually a version of Unix, on their own proprietary hardware. If I wanted a Solaris operating system, it had to run on a SunSpark processor. The applications were written specifically for that architecture. This represented multiple challenges for the industry. Customers were locked in. Developers would have to recreate their applications for multiple different architectures. Interoperability between systems was extremely difficult and cost prohibitive. With the advent of the x86 architecture and the standardized operating systems, Windows and Linux, the stack got disaggregated, which allowed for flexibility, innovation, affordability, and finally, expansion. Due to this shift, while previously entire data centers used to have only one compute vendor, today in the same rack, we can have hardware from multiple vendors running the same operating system and the same application. Now, unfortunately, traditional networking is not as flexible. A network engineer wanting to introduce a new vendor in an existing environment has to do interrupt testing to ensure that everything will work as needed, expected, and sometimes as hoped. Much like compute architectures of the 90s, traditional networking solutions over the last several decades consisted of vertically integrated hardware and software stacks. The switch, the network operating systems, and the APIs available are all provided by the same vendor. If a feature is needed, for example, the user either has to wait for the vendor to deliver it or is forced to replace the entire infrastructure. These proprietary enclosed architectures inherently are costly to replace and force the user into a single vendor ecosystem. Excuse me. Now, with the expanded functionality and performance of merchant silicon available in the market, Dell became one of the first Tier 1 vendors to move away from its own proprietary ASIC. This shift was analogous to the compute shift towards the standard x86 architecture. Majority of the other networking vendors also followed the same path eventually. This set the stage for the advent of open networking, and in 2014, Dell disaggregated the network stack by introducing open networking that provided customers with choice of running either Dell's network operating system or a validated third-party NOS on a Dell switch. Open networking provided the industry with the next level of investment protection and allowed the customers to be free of a single vendor roadmap without going through a costly rip and replace of the hardware. The switch became a platform where the same switch function would be dictated by the NOS that was running on top of it. To democratize networking platform, disaggregation of the hardware from software with open networking was the first step. We still needed a standard open source network operating system analogous to Linux, where the industry can come, collaborate, and build upon. That is where Sonic comes in with its large, diverse community and modular containerized architecture. Born in Microsoft's Azure cloud, Sonic is built for automation, telemetry, and scale. The flexibility of the architecture allows for running containerized applications while providing a high level of redundancy. To follow the compute evolution analogy, we believe that Switch is the server and Sonic is Linux. Dell Technologies has been supporting Sonic from its initial days. Alongside Microsoft, we were the founding members of SCI. From a community perspective, we are engaged at multiple fronts, from platforms to documentations to test automation and software features. We continue to invest into Sonic by being active part of multiple work groups inside the community. As one of the top contributors to Sonic, we have contributed features like Management VRF and SFlow and are currently working towards a management framework. Today, Dell has Sonic support for 7 hardware platforms. Moving forward, all Dell Technologies data center switches will support Sonic. As mentioned earlier, Dell has a history in making complicated, closed technologies open, affordable, and simple. Open source Sonic, true to its roots, is a great fit for public cloud and hyperscale environments. But a lot of enterprises do not have the scale required to support, deploy, fix issues, and manage global logistics like the hyperscalers do. I'd like to introduce to you Dell Technologies distribution of Sonic, where open source innovation meets enterprise class support. With this distribution, customers will get support and deployment services, predictable roadmap, expanded, validated use cases with enterprise features, partner ecosystem to leverage the inherent automation and telemetry capabilities of Sonic. This is the next phase of evolution for open networking. With Dell's distribution of Sonic, we are bridging the worlds of hyperscale networking and enterprise networking. For network management, we are contributing to the centralized management framework to provide support for REST and open config models along with a unified CLI. Ansible playbooks will also be published. To ensure that the customers are supported, Dell Technologies Sonic will go through extensive internal testing and validation before each release. This will include feature testing with thousands of test cases, scale and use case testing, solution validation, and validation with ecosystem partners. Dell is and has been a trusted partner to a lot of enterprises as we have been supporting and maintaining infrastructure for decades. We are #1 in open networking and quite proud of it, and now are also the first vendor to publicly announce global tech support, including 4-hour mission-critical support across the globe for our distribution of Sonic. Support for Sonic will include Dell Technologies qualified optics, documentation, virtual labs, reference architectures, config and design guides, as well as white papers. This distribution of Sonic will run on Dell's PowerSwitch hardware, which are x86-based switches supporting the latest in merchant silicon innovation. From a speed and feeds perspective, 1 gig to 400 gig is supported. The platform support for these switches will also be contributed into the Sonic community. Now, we are fueling innovation by enhancing Sonic capabilities at all layers and contributing it back to the community. We are adding key control plane functionalities and features, most of which are developed with community partners and will be contributed back. We're also providing things like config automation and advanced telemetry. As mentioned, one of the key advantages of an open source project like Sonic is the ability to work with other community members to accelerate innovations. Since the code and APIs are open and accessible, an ecosystem can be created. At Dell, we are working with some of these partners to create this ecosystem around Sonic. As part of Dell's distribution, the solutions from these partners will be tested, documented, and supported either through Dell or directly by the partner. I would now like to highlight a few partners whom we are engaged with currently. The first partner I'd like to highlight is Optera. Now, network provides a lot of data through various protocols, flow metrics, and APIs. Optera with AI Pulse has the ability to ingest all these inputs and provide diagnostic and analytics based on the data. With config automation, topology visualization, flow and impact analysis, Optera allows for the user to extract meaningful results, observe, predict anomalies, and correlate them using its AI and ML engine. As a result, AI Pulse is able to pick out needles, meaning extremely hard to detect anomalies, including gray failures in the haystack, for providing faster root cause analysis, predicting failures before they happen, quicker remediation and event correlation, and real-time change verification in large-scale networks. Now, specifically around Sonic, Optera is integrating with Dell Technologies distribution of Sonic to make it easy to configure and manage Sonic in enterprises. Some of the key integrations include integration with Sonic telemetry models for comprehensive monitoring and AI-based anomaly detection, integration with Everflow for on-demand flow analysis, ping mesh integration for continuous and on-demand connectivity, and automated configuration of a layer 3 based leaf and spine network from scratch using Optera as the controller and Sonic as the NOS. The second partner I'd like to highlight is Appstore. Now, in a single or a multi-vendor environment, Appstore provides intent-based lifecycle management for operations with analytics. Appstore automates the design, build, deployment, and operation of data center networks to dramatically reduce OpEx, prevent outages, and accelerate deployment by aligning day zero design to day two operations. Appstore provides automated management of data center leaf-spine network services, real-time closed-loop validation using advanced processing data analytics, and seamless cloud-scale network deployments at web-scale levels. The final partner I'd like to highlight is Broadcom with their Broadview. Now, Broadcom's telemetry suite includes BST and IFA, and it allows for real-time traffic monitoring at a packet level. It provides packet-level visibility for path tracking and congestion monitoring. Also provides metadata around timestamping, port, QID, TTL values, etc. By leveraging in-band telemetry, Broadview enables scalable flow monitoring and delivers a network-level solution. With features like path tracking and mirror-on-drop, users are given the data needed to troubleshoot gray failures at an ASIC level. I would now like to highlight some of the use cases that we have today with Dell Technologies distribution of Sonic. These use cases are either currently in production with Sonic or are in proof of concept at customer sites. The first use case is the scale-out L3 data center fabric. The scale-out BGP underlay use case is used by cloud providers and large enterprises to simplify their networks. They intend to use higher layer software for application management. This design can be extended with multi-chassis lag and NIC teaming for redundancy use cases. eBGP and iBGP can be used in different cases for complete L3 fabric. In some architectures, customers prefer to use BGP to the host for redundancy. For Sonic, this is the most common use case. Moving forward, the next use case is the scale-out L3 fabric using EVPN as an overlay. This is the most prevalent use case for enterprise customers to stretch their L2 domain across racks and pods. EVPN provides the flexibility to create L2 clusters for applications beyond the rack. Both symmetric and asymmetric EVPN are supported. Multi-chassis lag at the top of rack provides redundancy and resiliency to the network at all layers. The third and final use case that I'm going to discuss is edge bare metal automation or metal as a service. This is an interesting use case where we can utilize the flexibility and the architecture of Sonic. Here, a third-party container can be deployed on the switch and can work with other containers in the management plane. This container can be used for complete bootstrapping of servers and storage in the rack. A complete workflow can be executed to get all the servers and storage to a desired state for application deployment. Example, installing the required operating system or creating the required VMs, etc., etc. In summary, by combining the open source modular architecture of Sonic with Dell Technologies innovation and enterprise level support, we are proud to be enabling the next wave of open data center architectures with Dell Technologies distribution of Sonic. Thank you.
Thank you, everyone, for attending our presentation on Dell's distribution of Sonic. I'd like to open up the forum for questions and answers. Please feel free to ask either on the chat or live as we are. So we have one question on the platform from Arcady. And the question is, in the context of optics, does this mean Dell will publish optics hardware compatibility list that was qualified with Sonic and Dell switches? Arcady, that is correct. From a perspective of Dell optics, we will qualify them and we will publish that list. Any other questions? Okay, I have a question from Eric. Is MLAG and Type 235 EPN fully working on Sonic? So Eric, from MLAG and EPN perspective, there are certain use cases that we are supporting right now, and we're going to continue to add to it and upstream it into the community as well. So for the exact details as to which pieces are supported or not supported, please feel free to shoot me an email, and we're happy to give you a response. But for the use cases that I displayed, BGP, EVPN, and MLAG is supported. Thank you. That's a good question. You're welcome, Eric. Folks, no need to be shy. We did a press announcement regarding our distribution of Sonic yesterday. And the idea is that we are the first tier 1 vendor that is coming out and with our own distribution of Sonic to make sure that enterprise use cases are supported. So this whole presentation was anchored around that statement. So if there are any questions right now, please feel free to ask them on the platform. Otherwise, just send an email to ale.hassan@dell.com, and happy to have a conversation around that. So we'll leave it open for another couple of minutes to see if there are any other questions. While we wait for the questions, I'm just going through the attendee list. I can do what my teacher used to do in the school and start calling on people. That's fine. I think that's pretty much it. Thank you, everyone, for joining this session. Would welcome any feedback, any thoughts that you folks have on the strategy, the direction, and even a conversation on what the offering is and how it can help you, the customer, the community overall. So please stay safe in these challenging times and enjoy your OCP, and hopefully we'll talk to each other soon again. Thank you very much, and have a great day. Bye-bye.